All right, looking at the next graph. Again, we have an exponential growth graph, which is great news because it's going to be similar, but definitely not exact, because these numbers on the y-axis are a little bit bigger. But no problem at all. We can handle that in a pretty easy fashion. So what is the growth factor? Again, that is b, what it's growing by each time. So I can make a table. Actually, I need to make a table here because it doesn't give me anything in the question. Like the first one gave me doubles, which tells me, okay, it's multiplying by 2 each time. This one doesn't give me that information. It tells me what it starts at, which is good to know, but I don't know what it's growing by each time unless I make myself a little table here. So let's go ahead and find what we can. So when x is 0, y is 10, which makes sense because we start at 10. When x is 1, y is 20. So it's looking like it's doubling too, but I'm not gonna, settle for that. I'm gonna keep going. When x is 2, y is 40. When x is 3, y is, 80? 80. So now I'm pretty confident that this is the same growth factor as the other one. So this one is multiplying by 2. So again, the growth factor being b is going to be equal to 2 here. So it's just growing by 2 each time. What is the initial value? So the difference here is where they start. This one starts at 5. This problem, it starts at, if you can't see that, yeah, you should be able to see that. It starts at 10. So my initial value is at 10. Now, if you didn't want to read the graph and all that was too confusing, you could have looked at the table. When x is 0, what is y? If you didn't like that, then you could read the problem. It helps. Starting at 10 bacteria. So starting and initial are synonyms, so that should give you an indication on what you start with. The reasonable domain here, again, we're dealing with time. And on the x-axis, the domain is time. So we can't have a negative time. So the domain can be anywhere between 0 and time can go on forever, although we won't live to see it, but it can go on forever. So from 0 to infinity is the reasonable domain, because we can't have negative time. No one time travels as of yet. And if this is the domain, then the range is when x is 0, so it starts at 10, all the way to positive infinity. So you can grow this bacteria forever, and it'll go to positive infinity. What is the interval between 1 and 3? The interval here, I believe that's the average rate of change they're asking for. So the arc, the average rate of change. So just like you did in the question before. So when x and y, when x is 1, when x is 3, that's 20 and 80. So y2 minus y1 divided by x2 minus x1. y2 is 80 minus 20 divided by 3 minus 1. 80 minus 20 is 60. 3 minus 1 is 2. So 60 divided by 2 is 30. So the average rate of change is 30. So the difference here is, they start at different places between this graph and this graph, but also this one is changing faster between points 1 and 3 than the first graph.